Hi, guys. Okay, so we are going to do the learning check problems 5.1 and 5.2, which relate to measuring heat. And here we have a problem 5.1 in which I believe there is a misprint, if I'm not mistaken, but the question reads that how much heat in joules must be added to a 5.07 into 10 to the power 4 joules of iron skillet to increase the temperature from 25 degrees Celsius to 250 degrees Celsius. The specific heat of iron is 0.449 joules per gram degree Celsius. Now, here, I believe if we are just looking at the units, then the heat is already provided to you. The answer is already there. So the heat is measured in joules. And so that's already in the question. So if the question is only testing the units, then your answer is 5.07 into 10 to the power 4. But let us just assume that there is a misprint. And instead of, this number, they are saying the mass is given 5.07 into 10 to the power 4 grams. So in that case, what would be the heat? So here we are going to use the formula Q is equal to mass into specific heat times the change in temperature. So what is the change in temperature here? We have the T final, which is 250 degrees Celsius, and we have T initial, which is 25 degrees Celsius. So you subtract the two and you will get 225 degrees Celsius. Okay, so that is the value for delta T. We are given the specific heat of iron, which is 0.449 joules per gram degree Celsius. So you're going to substitute that value here. The change in temperature is this. And then the mass, for the mass, you're going to use this number and apply it here. So when you multiply the 3, this is what you get. Okay, so we get 512.19 into 10 to the power 4, and the units of grams and, grams and grams cancel out, Celsius and Celsius cancel out, and you are only left with the unit of joules. Now we need to convert this into scientific notation. So you're going to move the decimals and you will get 5.12, and you can drop off the rest into 10 to the power 6. So you moved 2 places. So that is the joules, and that is the value of the heat in this question. Because like I said, if there might be a misprint, so that should be the answer. Okay, so let's look at the next question. Okay, so here you are given the unknown metal. The weight of the unknown metal is 217 grams, and you are given the heat that the metal absorbs, and that is 1.43 kilojoules. The initial temperature, 24.5 degrees Celsius, final temperature, 39.1 degrees Celsius. And you're being asked to find the specific heat and the identity of this particular unknown metal. So the formula still remains the same. Q is equal to M times the specific heat times the delta T. And the delta T is equal to the T final minus the T initial. So here you have 39.1 degrees Celsius minus 24.5 degrees Celsius. And then you subtract it, you get the answer 14.6 degrees Celsius. Okay, so that is the value of delta T. Now let's rearrange this equation. So we are given the value of Q. We have the mass and we have the specific heat. We need to find the specific heat, but we have the value of delta T. So when you rearrange mathematically, this equation becomes Q over the mass times the delta T is equal to the specific heat. So it's the algebraic conversion. Okay, so now important thing here is the units. So if you look at the unit, this is in kilojoules, and the specific heat capacity or the specific heat of a substance is in joules. Joules per, that's the formula. The specific heat is going to be in joules per gram degrees Celsius. So when we have something that is in kilograms, we need to convert it into grams. So the Q, which is 1.43 kilojoules times 1,000 joules over 1 kilojoule. So that is the equality. 1 kilojoule is equal to 1,000 joules. So when you rearrange, and so you get this, that kilojoules and kilojoules then cancel out. And you are left with the joules, which is equal to, so Q is equal to 1.43 into 10 to the power 3 joules. Okay, so now let's plug in all these numbers. So we have now specific heat is equal to 1.43 into 10 to the power 3 joules over the mass. The given mass is 217 grams times the change in temperature, which is 14.6 degrees Celsius. Okay, so when you do this, so we see that this comes out to be, when you do the math, this comes out to be 0.45 joules per gram degree Celsius. Okay, so that is the specific heat of this object. Now, the question is identify the identity also. So you are going to look at against the tables. So look at the tables in the book or even in the internet and look at the specific heat capacities or the specific heats of other metals. And the one that's closest to this one is iron. So that's the identity of this particular element, okay, of this metal. Okay, so next video we're going to look at the calorimetry. Okay, thank you. Bye-bye.